Hello, hello. Giving things a few minutes to fire up across all the channels before I start saying anything really of importance. Do do do. All right, looks like we're live. At least on Twitch, I can tell we're live. Welcome to the stream this week, everybody. My name is Brian Morrison. I'm a software developer, and I'm here to school you on all things cool and cloud. So for those of you who haven't been following along, I run a Discord server. We have a bunch of developers that are on there, and every week we're doing weekly cloud challenges where we're going through Azure in particular. Right now we're eventually getting into AWS, maybe GCP, maybe DigitalOcean. I don't know, maybe something else out there I haven't even thought of yet. But we're picking one kind of core technology, running with it, and trying to figure out how some of this stuff works. I say try because myself too. I don't know everything about Azure. I like to think I know a decent amount, so that's why we're going to try and learn some things as we go. So today's topic is Docker containers inside of Azure AKS, which stands for Azure Kubernetes Service. Kubernetes is an orchestrator for Docker containers. I'm lightly familiar with Kubernetes. I conceptually understand what it's designed to do, but I don't know the ins and outs of how to work with it. So I'm excited for today's stream because I'm going to learn a whole lot of stuff today too. Okay, so before we get started, if you haven't checked out the Discord, brianmm.chat, pop that in your browser. It's a quick way to get directly to that. We're doing these things every week. You can also go to my website, brianmorrison.me, and learn some stuff about why we're doing this and how we structure it. I have to update the post that is going to, but you could still go there. I guess with that, let's just go right into it. Before I start actually in Azure, I guess I'll go over kind of the idea, like the outline of today's thing that I'm doing. I'm going to start off by building a small web API in .NET Core, and we're going to pick a project template that already has the Docker file along with it. We're going to step through the Docker file. I'm going to try and explain a little bit about what it does and how it builds the container. We're going to fire it up locally, and we're going to test some things using Postman, make sure that everything is going smooth there, and then we're going to try from there to deploy it out into AKS, and that's the part where, like I said, we're going to figure stuff out. Before I even start with some of that stuff, though, I figured I might as well take a moment and kind of explain containers, what they are, why they're important, and why they help, and why they're so helpful. So we're trying out a new technology. I'm using Microsoft Whiteboard. I've used this a little bit in the past with mixed results. I haven't used this in probably about a year. So hopefully this works pretty well. I'm going to be sketching on my iPad. It should be showing up directly on the screen. Before we do that, though, I'm going to start up some music because I like music. All right. 90s Hard Rock Essentials. How about that? That's a good album. That sounds like a good playlist. At least iTunes is telling me it's a good playlist, so we'll see. I've got it playing for anybody who is in the stream and watching. If you guys tell me if the volume's too low, too high, if you can't understand me, let me know. Let's see. I'm going to raise the volume a little bit because I do have it kind of on the lower side. So we'll leave it there and see how this goes. So what are containers? What is Docker? What solution or what problem do Docker containers kind of fix? The main cool thing you can do with a Docker container is it lets you take all of your code or somebody else's code and run it inside of kind of a mini virtual machine on top inside of your computer or inside of some kind of underlying platform like Azure AKS or AWS has their ECS service. So it allows you to have kind of a nice baseline. So everyone who's working on some code can all know that this is going to run inside of this particular environment. So without diving too far into kind of infrastructure type stuff, I do think it helps to explain the different layers of compute abstraction that exist. So in the good old days, you had a server. Make sure this is actually showing up on the screen. And a server was this collection of say, a Windows operating system or Linux operating system. You had some software installed on it, which would be your actual applications directly on the bare metal. You could have databases running. on there, and then it goes on and on. It's like a regular computer. So a server is just it's a big piece of equipment. It's like a regular computer, but it's a lot more powerful. And it has a special operating system that allows things to kind of connect to it and do different things, right? So from there, then you go into like a virtualization environment. And now in virtualization, this is where you get into things like Hyper-V or VMware. You have your same server, but you install a special kind of operating system called a hypervisor on there, and that hypervisor is made up of different VMs. So now instead of requiring one server to run to be dedicated for one particular thing, you have all these different virtual machines on here. And a virtual machine is just like a server without the actual physical hardware. So inside of one of these VMs, you'd have your OS in here, you'd have your software in here, you'd have your database in here, and so on and so forth. And these could be say this could be Windows, this could be Linux, and if you're extra special and have like Mac hardware, you can even run OS 10 in here, and so on and so forth. So this would be kind of the virtualization model. Now, containers kind of take that a step forward. See, like when you have a VM spun up and you're using virtualization, you have to install the operating system, and you have to install all of everything that you want to use everything you want to use for that particular virtual machine inside of that operating system. Containers, like I said, take this a step further. So we'll blow one of these things out into its own little square, right? So this would be like your virtual machine. Now, this doesn't need to be a virtual machine. This could actually, the Docker system can be installed directly on top of the bare metal hardware if you really want to. But inside of here, you have these containers. So this would all be like a shared operating system. So the best example is Linux, right? Linux has a lot of different packages that are installed inside of it, and that keep the whole thing on running. So a container inside of here. So this would also be running the Docker software. So these little blue things would be containers, and these containers only contain just your software. It contains just the software that's compiled and running on there, along with any of the absolutely needed dependencies for your software package. But one of the cool things about containers is it will actually use some of the underlying libraries that the host operating system has with it as well. So the different containers only will use the components that are already installed, and then they will reach out to what's called a repository, I think, and they will download any extra components they need, like an underlying you could run a whole operating system actually inside of a container, but the main important thing is it shares what it needs with the host operating system and runs only what you want it to inside of there. And the reason that's important is because, like you'll see today, I have Docker Desktop installed on my machine here, and I can fire up a container it'll build a container and it'll run it directly, and we'll be able to interface with it. I'm going to go through some of the cool different commands, at least I've used, that have been helpful over the last couple of years since I've been using this stuff. And you can interact with it just like it's running inside your computer. But since it is a container, you can actually take that image and you can send it out. Containers are based on images. You can take the image and ship it out to another service and then run that container there. So this way, it's this nice little package that can be run across all sorts of things. So hopefully I did that justice in explaining it. I don't think there's any need I need to sketch out anything here. So we're going to put the iPad down, and we're going to kind of get into some cool things here. So I will share this image out with the Discord if anyone does care to see it. So with that, let's go ahead and get started into the code. So I'm going to open up Visual Studio 2019. If you're running anything .NET, Visual Studio is the way to go. I like VS Code, but like I've said, I made the argument in my last stream that you use the tool that's best for the job, and I think Visual Studio is best for this job. I've tried using VS Code, and I wasn't a huge fan of it, but that might just be because this is what I'm used to. So we're going to create a new project. You can see in my recent project templates, I have ASP.NET Core Web Application already selected on the left-hand side because I just built something with this recently. And then there's been tons of different templates and things you can use in here. So if you don't see it on the left-hand side, you could just search in ASP.NET. Spell right, ASP.NET Core, and it should show up as one of the first ones here. We're going to be using C#. You see there's F# available if you're nuts, but we'll just use this one. And I actually don't know if I have my repository pulled. I just blew away this computer not too long ago. Yeah, here's reference projects. We'll do Here. All right, so here is the repository that I'm using to track all of the weekly challenges that we're doing. So in here, let's see, what do we want to name this? We can create a new folder and say just web API. Store that inside of there. Okay, web application one's probably fine, but let's say AKS API. AKS API. Go ahead and create a new project there. Now you can see it's going to give me a couple different options. You can create an empty project, which is what we did last time. I'm going to take a shortcut this time and select API because it's going to kind of bootstrap a bunch of stuff for me instead of making me have to create it manually. So we're going to go ahead and select API. On the right-hand side, you can see we have configure HTTPS. Now, I'm not going to do that because I really don't care too much about HTTPS. There's nothing really secure happening with this application, but also I'm a firm believer that it's the responsibility of something like a load balancer to handle those kind of secure the secure connections, because you can offload some of the responsibility from your containers to your operating system, save some cycles, and let the load balancer handle that termination. And then from there, from your load balancer, it would proxy any kind of requests off to the application just using standard HTTP. But what I am going to select is this enable Docker support. Again, we could write this ourselves. I'm going to kind of cheat so we can get through this a little quickly and get into the cool stuff, which is this, getting into AKS. I'm going to select Linux because I'm running Docker desktop here, but I'm running it with Linux, with a Linux container, which if you are running Windows, I think if you're running it on Mac and Linux, it just installs the binaries there. But if you're running it on Windows, you need to have, I think, Windows 10 Pro, because it does install Hyper-V, which is that hypervisor operating system or the functionality that I talked about earlier. And it will actually add a VM into there, which the Docker desktop client uses to interface with the VM and spin up your containers and whatnot. Because we're running Windows, we're not running Linux. So let's go ahead and leave that set to Linux and click Create. And let this do its thing. All right, so if you did follow along with weather forecast, I guess it added some extra stuff to it. So if you followed along last time, I created a couple controllers in here. Program.cs is one of the entry points to the application. Startup is where a lot of these things are registered. We went through a lot of this, so I'm not really going to touch on a whole lot of this from last time. Let's take a look at this dummy API that is spun up for us. Okay, so yeah, so this looks like this is going to choose one of these random things. It's going to return a temperature and send it all back. Looks like it's going to get a list. Let's go ahead and fire this thing up. I'm not going to choose Docker for now. I'm going to choose, the AKS API. This will run inside of an executable. So we're not getting in any of the Dockery stuff yet. So let's go ahead and run this. Okay, so that's building out. It opened up a web page over here, which we can change and fix that later. Yeah, hold on. One of the things that I hate that VS Visual Studio does for you automatically is when it creates one of these packages or one of these templates, it will automatically tell the IDE to launch a web page when you start the thing. Which I don't want to do ever, and I always forget. Here we go. This launch browser, we're going to uncheck that because we're running an API, we're not running a browser. I don't want to actually launch another browser window. All right, let's fire this guy up again. Okay, now it continues running without the web browser. So I have Postman open, which if you're not familiar with Postman and you're working with APIs, you should get familiar with Postman. Let's go ahead and create a new request here. This is a very good way to test APIs and pretty much anything that's web related. So we're looking for localhost 5000. So let's type in our address here, localhost 5000. And it says 404 not found. This might be because it's looking for that API path. Just controller, I don't see anything there. Oh, you know what? I bet you it wants that weather forecast. There we go. That's what I was expecting to see. So it's just returning some temperatures, dates. Yeah, so cool. We got data. That's the important thing, is we're seeing some stuff come through. But the other thing I wanted to point out here is, if you notice inside of the route here of this open square brackets, the square brackets are here. I have controller in here. That means it's going to look for everything before this here. That's why I knew that weather forecast was what it was looking for. I've very recently started working with more of this .NET Core stuff, and I did notice that seems to be how a lot of these controllers that are created by default are set up to do. So it's looking for this right here. You could replace this with anything you want to, and then that path after the :5000 is then it would be looking for. Okay, so API is up and running and cool. Now I'm going to switch this over to Docker, which this is one of the really cool things I discovered recently when playing around with this stuff in Visual Studio, is if you run this in Docker, it will deploy out the container to Docker Desktop, which it should detect automatically, but it will also run, I believe, what's called a remote debug session with that container. So you can actually set breakpoints and stuff inside of Visual Studio. Let's see, container warm-up is in progress, so it's doing something. But you'll see we can set breakpoints inside of Visual Studio, and we can fire a request off to that API, which is actually a Docker container. And it'll stop at the specific breakpoints. So we can analyze some of the data, some of the things that are happening, just do some debugging. See the container tools output pane for details. I don't see a containers tool tab. Oh, there we go. So it's doing some stuff. While that's doing its thing, I'm going to open up PowerShell session, which is the way that we can use to interface with Docker, the Docker daemon directly. The Docker PS means I'm looking for any running containers. Docker PSA would show any container at all. See what it's doing. Yeah, I'm going to share out to Docker Desktop. The little notification popped up that asked me if I wanted to share out my local drive to Docker so it has access to things. And yes, we want that. Okay, so now you'll notice my Visual Studio interface kind of changed. Things on the bottom are glowing red. That means it's fired up and it's working. So Docker PSA, you can see this is the actual container that's running here. I don't know if I can make this any bigger. $36. Oh, too big. Sorry, let me take this back a little bit. Let's try 24. See how that looks. That looks a little bit better on the stream. So is it gonna? Yeah, it's gonna restrict me. It's gonna try and return some of this stuff. So these different columns all kind of map to something, right? So container ID. Here's your container ID. If you're issuing any kind of commands into Docker, the container ID is usually a pretty good. It's the best way to go directly to a container. Although I have noticed recently you can use name. Which is this AKS API, so I can do like a Docker, Docker RM, Docker, just different commands that Docker accepts using that container, the container name, and it should accept it. So let's see what else we got here. We got an image, AKS API :dev. That's our image that we're using for this particular container that's running. This is the command that's used to start up the container. So it's tailing something to. Interesting. I don't know what it's actually tailing to. This is more Linuxy stuff, but it's trying to follow. I'm guessing dev null, and if it doesn't actually, this might just be a trick that it's used that this container is using just to stay open. Because when you start up some kind of binary inside of a Docker container, it needs to be something that's constantly running. It can't be something that starts up and then quits. Because once it quits, once that the binary, the command you've issued into the container quits, the thing just stops. So here's when it was created 44 seconds ago. It's been up for 44 seconds. That's the status. Ports, this is really important. So this looks like this is saying I'm taking port 32, see, because it wraps around 32768, and I'm forwarding it off to port 80 using TCP. So there is some kind of networking knowledge that is kind of required with Docker. So this is port forwarding, that 32768 over to port 80. 80 is the default HTTP port for a web service. So I should be able to issue commands to that 32768 into 80, and it will respond on that port as opposed to 5000. And then here's the name, which is AKS API. So let's see here. Let's test this. So instead of doing localhost 5000, I'm going to do localhost 32768. See if this works. Send it, and yeah, you can see here's the response for that API. So that is forwarding off the way that we expect it to. Let's see. What are some cool commands that I can go? How about Docker? Docker PS I showed. Docker PSA I showed. Docker image ls will show your images that you have on your computer. You can see this AKS API is the one that we're running. The tag is dev. If you ever see this kind of syntax here where you have under the image, it has this is the container name, and everything after the colon is the tag name. And tag can be related to a lot of different things. A lot of what I see is version. So if you have multiple versions of a container, usually the tag is the version of that container. You could also see we have an image ID, which looks very similar to our container ID. If you're operating on images on the computer, that's how you would operate on those as well. Because I'm going to kill these containers just to show how some of these commands work, and we'll kill the container. We'll remove the container. It's also important to know that just by stopping a container does not mean it is removed. It will still be stored offline in the background until you go in and move it. And then also, same thing with images. So like, I like to work with Docker Compose a lot, and one of the things I've noticed is if you kill a session for Docker Compose, even if you start one up, it will check. The Docker command line the Docker client will check to see if that image still exists or the container still exists, and it will start it up if it needs to. Really cool, but it'll throw you on a wild goose chase if you're making edits to your Docker file or your Docker Compose.yaml, and it's not taking any of those changes. I learned that after about 4 hours one day that, oh yeah, I need to go back and delete all the old stuff. There are some cool things you can do with that. I don't think we're going to really get into Docker Compose too much today. We'll save that for another session. But from there, let's see, Docker, here's a good one. Docker exec mean IT. Exec means I want to execute a command. IT means I want to do it and go and jump into the container while I do it. So if you do Docker container exec or Docker exec IT, we'll take our container ID, put it there, and then for Linux containers, if you do bin bash, you will actually drop into a terminal session inside of that container. So I'm inside of the container that Visual Studio created. ls, I can see here's all the files that are in here. It's inside of this app directory. I can cd up. Cd, for those of you who are not familiar with Linux command line, is change directory. .. means go up the path. And ls, and then you can see here's the root of this particular container. So if you're ever doing things like copying files into it or mapping it, and it doesn't seem to be quite what you're looking to do, you can jump in here and work directly inside of the container, which is really helpful. Now, another thing I've used this with is if I'm trying to issue like startup commands and stuff, and I'm expecting it to work, but it doesn't seem to be working or throwing an error, I can jump into a terminal. I can jump into the terminal session inside of the container and issue those commands manually just to see what it does. Really useful for debugging. So exit will jump you back out into the main operating system. Let's kill our container and let's go ahead and remove it so I can just show off some of those commands. So Docker PS to show our container. We will do Docker kill and then our container ID. And you can see it, yeah, Visual Studio is complaining because it didn't expect that. It wasn't in control of killing that debug session, so it's just complaining that it died. So you'll see whenever you issue a command and it is successful, it will return the IDs of whatever objects or entities you issue those commands against. Because even though right now I only have the one container and I use Docker kill against that one container ID, you can actually specify a bunch of container IDs after that, and then it will do it to every single one of those. So you'll notice, even though I kill that, if I do Docker PS, it's not there. But if I do Docker PSA, it still shows up, and you can see the status under here is it exited 32 seconds ago. So the container still technically does exist. And if I wanted to start it up again, Docker container, I think it's start, and then the container ID. And there you go. Now the container's run. It's started up. Docker PS. There you go. So let's go ahead and kill that container again, and now we're going to remove it altogether. So if you ever want to remove a container, it's the same Docker, but instead of kill, it's RM, which is common for remove in Linux operating systems. And now I can do, let's see, Docker PS. Can we see that on stream? Yeah. Docker PSA, they're completely gone. Docker image ls, we can kill our image here too by Docker image. Oh, I made a bad word. Docker. This is why the stream is technically rated mature, because I have no control over some of the things I might type, and I have no control over the music that I play. So, all right. So Docker image rm, and then the ID of our image, and it deleted everything that might have been a possible dependency for that because it doesn't need it anymore. So now if I do Docker image ls, you can see all we have is our .NET Core ASP.NET base container image, which we'll go into in a moment here. So now we're going to hop over to back into Visual Studio. Let's go ahead and just to prove a point, we're going to start up this thing in the container again. If you can see, I know it's probably a little small in the stream, but up here I can change my startup. It did say Docker. All right, so now if I set a breakpoint inside Visual Studio, which you can do by just clicking something off to the left-hand side, one of the neat things you'll see is if I issue the same command into the container, oh, I might have mapped it to a different port. Let's see. Let's come back in here and find out what word Docker PS 32770. It switched ports on me. 32770. I wonder if I can still do 5000. It might still let me do that because Visual Studio is handling it, but now you can see that remote debugger in action, how I issued the command, and now it stopped at my breakpoint. So now I can take a look at some of the other things that might be going on here and be like, oh, you know, what's going on? What is this variable set to? If you're looking for specific data, you can analyze your variables. Really useful stuff that you can do in Visual Studio. I'm sure you can do this in VS Code as well. I'm just not as familiar how to do it. So, and like I said, use a tool that works. So we'll click continue to let it go, and now it finished sending the command. Other nice thing about Postman, Postman is really good about waiting for things to kick back. It doesn't time out very quickly, which is nice. So you can leave a session open. You can leave a debug you can leave the session kind of locked or at that breakpoint for quite some time to peek through what you need to before it'll complain. Okay, so there you go. There's the examples we got there. So let's go ahead and stop this. And here is our Docker file. Now, every Docker file has a couple of things that I guess are required. So, and some of this is actually kind of new to me after creating a project similar to this earlier as a template as a base to work off of. I'm able to semi-analyze what's going on here, which is pretty cool, but I don't 100% know. So we'll step through this as best I can. So this from command right here, you can see first off, this is commented. But this from command here, this is looking for a base image. So the image that we're going to start off with is ASP.NET 3.1 as base. So it looks like it's actually casting this image that it's creating into this variable called base, because you can see down here it's grabbing that image and it's doing something else with it. So we have our base. We're setting a working directory of /app, which you did see when I jumped into that container, and it's exposing port 80, which that's where that web I guess binary is running on, is it's listening on 80. So you need to tell the container when it's being built that I'm going to expose port 80 to the outside world. All right, so moving on there, it looks like we're creating another container here as the build container. So we're setting a work directory, basically a starting point of src. We're going to copy in this AKS API /AKS API.csproj, which is our main project file. We're going to copy that into AKS API, which it looks like it's creating a different folder for that, and it's going to run a .NET restore. So .NET restore is going to go out and grab any NuGet packages, any dependencies that have been registered with the project. It's going to go out and grab them, pull them in. Let's see, copying everything else from here. So it looks like it's actually going to copy in the project file, do the restore, and then copy in everything else. And now it's going to change the working directory to AKS API, run a .NET build, which will output it to /app/build. All right, so now it's going to take this build image and it's going to run this command .NET publish into /app/publish. So it's creating a release, a compiled release of that, which is this down here. You can see this AKS API.dll. And now it's going to take from the whole thing as the final one inside of our working directory, which is /app, copy from this publish image right here into app publish. Oh man, my eyes are going a little weird staring at this. So from the publish image, it's going to copy it into there. And then the last command, this entry point. So this is where I was talking about earlier, how it needs some kind of command, some kind of long-running command to keep itself alive. It's going to run the .NET command and pass in, that's your command that's going to be executed, and it's going to pass in AKS API.dll, which is our compiled assembly that we created, into it, and that's the image. And that's how Docker is going to know how to do something with this. All right. Now the fun stuff happens. Now we get to figure out how to get all of this up into AKS and actually have it do something. So before I even do that, I'm going to minimize this. And we're going to go into Azure Kubernetes Service. So all I've done is I've logged into Azure and I've clicked on Kubernetes Service. As you can see, I have nothing set up here. So we're going to create a Kubernetes service. And we're going to step through this all completely blind because I have never done this before. I've attempted to do this before, but I've never actually done it before. All right, pay-as-you-go subscription, resource group. We'll create the challenge resource group that we chose last time. Kubernetes cluster name. Let's see, cloud. Let's do cloud challenge, AKS, KUB, for Kubernetes. Let's see here. So region, central US, that's fine. Kubernetes version, I wouldn't even know what to pick here, so we're going to leave the default. And here's the DNS prefix. Don't know what that is, but I'm actually going to copy this and save this off to a notepad that I've open over here so I can keep track if that actually does become important. Okay, node size, standard DS2. I'm sure this is not going to be free. Let's take a look and see what offerings they have here. Cost per month, 106. Jesus, I'm gonna have to kill this when I'm done. All right, let's just pick that one. We're probably only gonna be running this thing for a very, very short amount of time. All right, let's select the cheapest one we got here. Okay, the number and size of nodes and pools, you need at least 3 are recommended for resiliency. Let's drop this thing down to 1. We'll go to 3, just for the sake of the exercise, but I need to make sure I kill this right before we're done. You'll not be able to change node size after cluster creation, but you will. Here, let's zoom in on here actually a little bit. If you would like additional node pools, enable the X feature on the scale. Whatever, we're just going to go ahead and make next. Let's see, enable scaling sets. Virtual nodes allow burstable scaling backed by serverless Azure container instances. Now, what's really cool about that, it seems to indicate that, I mean, VM scale sets are required for auto scaling of multiple node pools. So I guess that's kind of really one of the other important things that comes along with containers is if you have like a baseline image that you know it works well and is good, and you've registered this with AKS, I'm guessing it can use that to automatically figure out, like, if you have a large load, a large amount of incoming traffic into your site or your service or whatever, it can just start spinning up more containers on more nodes to kind of balance the load and keep things up and running. And same thing, you could have it monitor containers to say if it fails, if a container dies, restart back up. I'm going to leave that enabled. Virtual nodes, burstable. Let's just go ahead and leave that just the way that it is. Authentication, default service principal. Sure. See, cluster infrastructure service principles used by the Kubernetes cluster to manage cloud resources attached to the cluster. Kubernetes Authentication Authorization is used by the Kubernetes cluster to control user access to the cluster as well as what the user may do once authenticated. I'm just going to go ahead and accept this. You can choose basic network settings, including HTTP application routing, and configure your network. Basic or advanced. Basic creates the new VNet for your cluster. VNet is a virtual network within inside of Azure. And advanced networking allows clusters to use a new or existing VNet with customizable addresses. So it looks like if I wanted to go into some of the more advanced networking stuff here, I could do that. I don't, because we're just going to keep going with the defaults here. HTTP application routing solution makes it easy to access applications that are deployed to your cluster by creating publicly accessible DNS names for application endpoints. This will create a DNS zone in your subscription. It sounds like this is going to turn on some of that load balancing stuff that I was talking about earlier. HTTP application routing is designed for easily getting started with ingress controllers, and as such is not recommended for production clusters. Interesting. Enable this cool feature, but not in production. I'm guessing that means they probably want you to throw this stuff behind an actual, like an Azure load balancer. I will leave that as the default. Next, monitoring, container monitoring. Let's see. Yeah, this is some of that failover and auto-scaling stuff. With Azure Kubernetes service, you will get CPU and memory usage metrics for each node. You can configure, or you can enable container monitoring capabilities to get insights into the performance and health of your cluster. It will be built based on the amount of data ingested and or your data retention settings. Enable container monitoring. Yeah, why not? I'll just have to remember and delete all of this stuff right when we're done. Tags, we don't need a tag. We don't care. Tags are a way to tag things in Azure. You can give anything any tag you want. So you can think in like a real working environment, if something is dedicated to a specific department, you can create a department tag and tag it to the finance department or tag it to the operations department. All right. Validation passed. Let's go ahead and create. And we can monitor the deployment, I think, by clicking this guy up here. It's initializing the deployment. Hopefully this doesn't take too terribly long. Last time I did this with the API management service, this took somewhere in the realm of a half hour to do a deployment, so I'm really hoping this doesn't take that long. How's chat doing today? Anything fun or exciting happening right now? I don't really have a whole lot of filler to be happening right now. I'm actually, while we're waiting, I'm going to go and look for Azure AKS Quick Start. I think there is a Quick Start guide that might help us go down the right path of deploying out what we need to. So this says create an AKS cluster that supports Windows Server containers, which I don't really think we want. See group Kubernetes. Okay, so this is using the Azure CLI. To manage a Kubernetes cluster, use kubectl, Kubernetes command line client. If you use Azure Cloud Shell, kubectl is already installed. That's pretty cool. I've heard about a lot of this stuff. Hey, Godbleak, how you doing? Godbleak says, not too much. Is that community folder in your bookmark the show community? Oh, no. You're talking about right here? That's the church I attend. It's Community Christian Church. I do some work for them as well. So just doing pro bono work. So good question, though. Creeping on my bookmarks. Sorry, I don't mind. If I really cared, I wouldn't leave that stuff there, but I'm not the most private of people. Not a lot of stuff bothers me that I want to keep secret. I'm really like, okay, cool, we're done. I'm really anal about like the right stuff, like passwords and stuff. Like I'm really, everything I got's like I use LastPass, you know, completely random passwords, two-factor authentication and everything. So, but when it comes to like personal life and stuff, there's not a whole lot that I'm really cared. Oh, that's still doing stuff. So a workspace deployment's done, solution deployment, and that is still going. Let's head over to the Kubernetes service and see what's going on here. What is this? Kid Rock playing? All right, distracted. All right, so it still looks like it's still creating here. Let's go ahead and minimize that. I guess while we're doing this, we can kind of poke around a little bit and see what some of the options we have are. Let's see, node pools. You can add node pools of different types to your cluster to handle a variety of workloads. So node pools, I'm guessing, are Azure VMs. Yeah, I kind of thought that even though Azure Kubernetes Service is kind of like the management layer for all this, it's still using VMs on the underneath. It's just kind of hiding it and tucking it away so we don't see it or don't have to manage it directly. This isn't a bad thing. I mean, it's pretty cool. I think AWS's Elastic Beanstalk does the same thing, where even if you use Elastic Beanstalk, it's still using EC2 instances under the covers. Launch a Docker app to your Kubernetes service in a few quick steps. What you drinking? Seltzer water. Being healthy. Nothing cool, Brandon. All right. Let's see. Are we still creating here? Yeah, I'm still seeing stuff going on. I'm guessing this deployment center is probably we're going to end up launching out from. Everything I have is in a Docker or in a GitHub. Let's pull up. Pull up my GitHub here. All right, so here is my GitHub. Let's go and push this stuff up. I don't want to do it from this folder, although I don't think it really matters. Yeah, this is weekly cloud challenges. So let's see. 2020.02, I think is what my naming convention was, .03. Oh yeah, year. .2. So I got year, I got month, I got the challenge we're doing here. I might honestly just nix out the month because we're gonna keep doing these over and over and over again. Let's see. 2020.3 built Docker API thing. Why not? Oh yeah, I gotta ignore this VS stuff. I wonder if I should just do that on the top level. Yeah, I don't have a Docker. I don't have a git ignore here. Maybe I do and it's hidden. Pulling up VS code. Or don't create the file. There it goes. Let's see, bin. I guess now I could do bin. Probably do that. OBJ, probably get rid of that. Clean all that stuff out. Did I ignore? Do I have one in here? I got a git ignore there. I'm gonna add node modules to here because we're gonna probably do some node stuff at some point. Node modules is like that monster folder that installs node dependencies. It's like, of a node project, your node modules folder is definitely always the biggest. All right, let's look here. Yeah, we dropped down to 13, so that's exactly what we wanted to. Commit that, sync it, push it. Right back. I don't, again, security. I don't share stuff like this out on a stream. All I'm doing is signing into my GitHub. I'm surprised that it's asking me for this because, oh, maybe it's because it's Visual Studio doing it. Because I pulled it from GitHub. Yeah, it's probably because it's Visual Studio trying to interface with it or interact with it. So, all right, we are pushed up to the cloud, to the GitHubs. Let's make sure it built the Docker API thing. All right, cool. So that's there. Let's check this and see what it's doing. Still see deployments in progress, but let's see if we can go to Deployment Center, what options this gives us. Go to GitHub, authorize. I'm signed in, so it shouldn't bug me again. All right, we're using GitHub Actions. Let's go ahead and authorize. I could have that in password already, so let's put that off to the other screen. Sure. Next. Dockerfile path. Oh, does this have a Docker? Yeah, it does. We just looked at it. So it will be in Web API, Azure AKS API, and Docker files in there. So would that mean I think I need to do this? Port? I don't know, 80. Docker build context. The source directory path which is used for building a container. The build process can refer to any files. For example, your Docker build can use relative reference files. Interesting. Signal boosted. I don't even know what that means, so thanks, I think. Grok sent me. I don't know who Grok is or what Grok is, but what's up, Smashington? Oh, cool. Oh, you're Grok. All right, Grok. I don't remember that. Thanks. I appreciate it. All right. Source. What are we doing here? Let's go ahead and pop open a new tab and see what it's see what's going on here. Oh, why did it do that? Build Doctor build. Oh, okay. Maybe it just needs a dot? I don't know. Let's try that. Container registry, create new. Cloud challenges registry. Standard. Let's do basic because I'm trying to do cheap and free. Central US. Okay, next. I don't see this here. Did we look at this earlier and I said it was done? Okay. Yeah, I think I did notice it was done. Deployment succeeded, so that's good. Configuring continuous delivery. Let's see what this does. Okay. Here's the thing. Is it doing anything? I don't know. Yeah, that goes to that. Adding. Oh, okay, so in GitHub Actions, it's doing something. Let's click in here. I've never actually used GitHub Actions, so I really don't know a whole lot about what this does. Job. All right, build and push image to ACR. This failed. Why did this fail? GitHub Workspace. No such file or directory. The cloud challenges. Oh, I'm guessing I have to. Okay, I probably have to get rid of the slash that I have in front of this. Can I modify this? Doesn't actually let me edit anything, which is kind of strange. Let's refresh here. No, doesn't like that. All right, let's re-add this and see what happens. Yeah, master, next. Okay. Let's go and copy that path from earlier like we used, but I'm going to copy this here. No such file directory. All right, let's try it like that. All right, so that's there again. Updated 2 minutes ago. Okay, we got more action going on here. Let's see what goes on here. Oh, something failed again. Unless it's the same thing. Okay. Okay, so this is the one I was looking for, but it says unable to prepare context, symlinks and dockerfile path. I'm not sure what to take away from that. This is running docker build. It's running this command. So like this looks like this is actually trying to run something. So docker build, GitHub workspace. The file, it's looking for Azure AKS, but there's no, it doesn't actually append dockerfile there. There's the tag. Right, let's actually do something for me. Let's pull and see if maybe it added something next to my file. Oh, I don't see anything there. I'd like to know how to delete these because I don't want multiples of these things hooked up here. Status badge, no. Adding workflow file. So it did do some stuff here. Not seeing anything in here. Oh, here's some stuff. Whoa, we're about opening this up because I don't know. Okay. Nothing special there. Let's delete some of these. Let's actually look at open with Sublime Text. So I'm wondering if all that really did was just create these files here, which do stuff in Azure. Okay, I don't see anything here that really looks of importance. Yeah, we're going to get rid of this too. I don't want that extra workflow. This is pretty cool with GitHub Actions. It looks like you can embed this stuff in here. I'm scanning through this file to make sure there's nothing worthwhile. No, it doesn't look like it. It looks like it created this file but it's injecting some of the like username and password and stuff in here, so it's not saving it along with it, which is pretty cool too. So we can get rid of this. I'm going to modify this, and we're going to change, because I was using Windows pathing on here, Azure AKS, AKS API, and then we'll do dockerfile, I guess, like that. Actually find our file. I'm not sure where the context comes into play. I'm guessing that has something to do with that. Probably is where that dot came in. All right, so we save that. I don't see anything else in here worth looking at. Let's try and push this back out. I'm actually going to command line this. So let's see. PowerShell, git, got all the files, git commit, modify GitHub Actions. Push that back up. And I would think that once we edited that and pushed it back up, it's probably going to trigger these actions to start working again. Modify GitHub Actions. Okay, cool. So it does. I'll build and deploy. I guess we got to click on this thing here. Oh, we got some action. See, here's building it's building the images. All this stuff that's floating past here, had we actually done this Docker build command directly inside of that folder instead of letting Visual Studio do it for us, this is what we would have seen. So it is definitely doing a thing. Doing a thing is cool. I like it. Oh, something broke again. Let us see what broke here. All right. Copy failed. Okay, so this is part of that copy. It's trying to copy the project inside. Now it doesn't know where this is. So I'm wondering if that has something to do with the build context. So we're in kind of a point where I'm just going to keep modifying this file and pushing it back up and seeing what happens. Now it's trying to run from... Let's see, can I see where the path is? I'm guessing it's running from... Maybe I do got to put this whole path in and do, let's see, AKS, AKS API. Maybe we'll try for the context. We'll do this here. I'm going to go back in here and see if I refresh this. It's going to get rid of that other one. No, it doesn't. All right, we're going to add a third one. All right, yeah, authorize. And what I want to see is if in the build context, see what changes when I do that. So, I don't know, dockerfile path, we could do AKS API dockerfile. Do that, do port 80, we'll do this is my context. I don't really expect this to work, but at least this will give me an idea of what needs to be changed here. So use existing is fine. All right, let's head over to actions again. All right, yep, right there. This is my context. It was basically saying I can't figure out where this is at all. So the working path, yeah, it's even jacked up there. So this is the working path. This is where it's trying to figure out where it needs to do the copy from, which I guess in hindsight, after I was reading the directions, does make sense. So let's go back in here, and I'm actually going to come here. We're going to do git pull all those commits that it was working on. We're going to go back into this where we were working. I'm going to get rid of some of this extra stuff we don't need anymore because that was created. We don't need that. Let's get rid of that. Go back into our workflows. Let's get rid of that extra one we created there. Now, let's fire this guy back up. And instead of here, we wanted, it was trying to work from this directory here, I think. So let's copy that into here, like so, because now the working directory is going to be here. So if our copy command inside of our Docker file is trying to copy from this AKS API folder and the project, let's actually open up this again. So it looks like it's actually working from here. Oh no, maybe not. It's trying to work from here. Because it's looking for, if you look at here, we're doing a .NET restore on this AKS, or copy AKS API.AKS API project. If I go into, that would basically lead me to believe I'm here. So I'm one layer up. Because I go into AKS API, there's the project. Or no, that's the solution. There's the project. No, we're right. Nope, back and forth. All right, so we modified that and we saved that, I think, right? No, we didn't. Save it. Here. Add it again. I'm going to do the same thing. Git push. Git push. All right, back into actions. Modify GitHub actions. Okay. Let's look at this again. I would expect we're going to get a little farther, I would hope, if I put that path in correctly. Just past the hour mark. We were a little slow to start today because I wiped my computer out earlier this week, and I actually had to install Docker Desktop, install iTunes, install Postman. Thankfully, I did Visual Studio earlier this week, otherwise that might have actually thrown this whole thing to the wind. I don't even know that we would have been able to stream tonight without Visual Studio. I guess I probably could have done it in VS Code. It just would have taken a whole lot longer to get the whole project up and running as opposed to using a default template. Come on, show me. Show me. I want to see you do something. Yeah, logged in. All right, we got past. Great secret. Running deploy. See what we're going on over here. Status succeeded. I'm thinking that's the build status. Node pools. If I can see the actual what's being deployed out here, that'd be pretty cool. Okay, so the action succeeded. It's free capability for AKS cluster value, build and debug in a cloud native application. No, I probably don't need that right now. Deployment center. Yeah, this doesn't really do anything for me. Yeah, it's probably stuff I shouldn't be sharing on screen. But again, I'm going to get rid of all this anyway when I'm done. All right, I don't see anything. Go activity log. Create or update managed cluster. This was 8 minutes ago, 16, 19 minutes ago. It's pretty cool. All different information about our nodes we got going on here. Let's check out logs and see what we have here. Welcome to Log Analytics. Yeah, it's fine. Here you go, container inventory. Ago. Nothing there sticks out to me. Container image inventory, no sample data. Well, I'm not gonna lie, I'm kind of stumped here as far as what's going on or what I'm supposed to be looking for. There's internal stuff. Did create a public DNS name. Here's the API server address. Let's put that into a browser and see what happens. Connection's timed out. Okay. No, it wouldn't. I guess it might be a different port. There's 80 I can try. No, I should default to that, not HTTPS, because I didn't put HTTPS in. Weather forecast? No. Didn't do anything. I've clicked through a lot of this stuff already. Scale, upgrade. No, I don't want to do any of that. That's kind of one of the cool things you could do with this. If you need more nodes, just boop, slider. Not gonna lie, I don't know what I'm looking for. Actually, you know what? Hold on. On the topic of that, HTTPS : // Ah, we did something. All right, so it doesn't like the cert. Sir, unknown issuer. Yeah, it's using a self-signed cert. Let's click on that. Status unauthorized. Let's see log. Let's look up how to log into a Kubernetes cluster. See, no, I don't want any of that. I guess I would want a dashboard. You know, unless I need to use the CLI to access it. Maybe that's why I'm not seeing anything. Maybe the containers are deployed out and I need to use Kubernetes. All right, you know what? Let's try that. Kubernetes CLI. Nope, not what I want. Latest binaries from this link. Oh, it's really just an executable? Wow. Okay, cool. Let's load up PowerShell from here. Yeah, Sabotage. It's always a good song to throw on. Well, it's got to mean the music's coming through all right. I think one of my last streams, it was like you barely hear it. Get one or many resources. So get, what does that do? Explain. Do H. Oh, not H. Oh, here's some nice examples. Get H. Let's see. Get pods. Get deployments. I wonder if I have to connect somehow. I feel like I would have to connect to something first. See, install and setup, verifying configurations. See it all the cluster info. Oh, you know what? I wonder if I can cheat and use the Azure built-in CLI. Bash, why not? Storage. I got about 5 more minutes of this in me. Might have to do a follow-up stream. All right, initializing Cloud Shell. Let's see. AKS CLI commands. Well, no, actually, hold on a second. We were here earlier, and it said something about the kubectl being already there. CTL apply. Yeah, see, this was some of the stuff I think I tried playing around with earlier. If you verify cluster, get credentials. All right, this looks like this is what we need to do here. All right, so let's paste that in there. It's not that. What resource group am I using? Let's open up another portal, another tab here. All right, resource groups. So the one we're using here is this 2003 resource group. So our little command line here, let's get rid of this dummy resource group they have and paste that in. Got to right click and paste it. And then for the name my AKS cluster, maybe I can do cloud challenge AKS kube. Cloud challenge AKS kube. See what that does. Merged. Okay, I didn't get a failure, so that's a step in the right direction. kubectl get nodes. Let's see what this does. I think I had 3 nodes. Okay. Okay, that's pretty cool. We're getting a step in the right direction. Let me maximize this because it looks like we're going to be working mostly from the command line at this point anyway. So kube, let's open up our PowerShell thing I had here. Let me look at what we got here. Kube, get pods, try get deployments. Yeah, because I think a pod isn't. Oh no, I did nodes, so I guess let me try get pods. kubectl get pods. A resource is found in default namespace. Could try get deployments. Get deployments. More resources found. Can try get services, I guess. I might just not know enough about Kubernetes to really make anything like be effective with this at all. Which means that I might have to do a file stream. This is kubectl. Let's see what else we got here. API let's see. Explain documentation of resources. On a particular image. Expose, take a replication controller service. And expose it as a new Kubernetes service. Create a resource from a file. Try logs. Print the logs for a container in a pod. Attached to a running container. I want to see containers. That's kind of what I want to see. Try get containers. Get containers. It doesn't have resource type containers. Describe. Use API resources for a complete list. API resources. Okay. So this might be everything that we can access here. Templates. Services, we tried, it didn't give us anything. API services. Sets deployments. Deployments didn't do anything for us. Replica sets. Jobs. Try jobs. I did deployments already. Nodes, pods, ingresses. Endpoints. I could try endpoints. Events. I don't know. Failed to create endpoint. Failed to create endpoint for service cloud challenges. Okay, so it's to try doing something. This was probably when we finished our last action. Endpoint cloud challenges kube already exists. Challenge AKS kube. No, because that's got something to do with the deployment of this whole thing. All right. We're calling it. I am right now, because I'm not really sure what I got myself into. Everything seems to have fired off fine, but the last thing kind of has me a little concerned. Well, I guess it's a warning, so it shouldn't really be a concern. But in any case, it is getting late my time, and I'm kind of at a standstill because I don't know enough about Kubernetes to be effective and get in here and figure out what to do. But at the same time, we did learn how to create the deployment, how to set up the GitHub actions in order for it to deploy automatically. And we figured out that we can use the integrated command line CLI utilities inside of the Azure portal in order to access some of the stuff. Thank you, sir. Appreciate it. Thanks for the comment. So yeah, I think I'm gonna call it for now. I'll do a little more studying on Kubernetes, and then I'll do a recap on some of the stuff next week when I do my stream again. So I'm out. Have a great weekend. Oh, one more thing I wanted to mention. Nextcloud challenges I'm looking at. These are the 4 that are going to be posted in my Discord, which is at brianmm.chat. The 4 that I think I picked, which might get some good stuff, is deploying front ends into Azure Storage Account and Azure CDN. Building VMs in Azure is the second one. Third is configuration management using Azure Key Vault, and the fourth is automated deployments using Azure DevOps. So that post will go up later tonight, probably tomorrow morning. I'll put the poll up. So if you are interested in any of those, keep an eye out. Other than that, I'm out. Have a great night, everybody. Thanks for joining. Bye-bye.